Okay. You have to push the button. Oh, awesome. Okay, cool.
All right. Hi guys, I'm Cathy and I'm majoring in computer science.
You can just play. I'm Audrey. I'm majoring in electrical engineering, and today we're presenting on the synthetic rural Alaskan microgrid model project.
Yeah, so at the start of this project, we learned that there isn't an existing microgrid model of rural Alaska. And so this means that researchers are having to reach out to communities and ask them for their private data prior to testing their ideas. So this doesn't mean that there hasn't been any synthetic modeling done, but it's been restricted to the lower 48. And as we know, Alaska is very different from the lower 48. So when we're talking about metrics, especially validation metrics, which are ways we check that our model is accurate, those lower 48 metrics just simply aren't applicable. So our goal of this project is to really zone in on Alaska and create that Alaskan specific model.
So at the beginning of this project, a lot of our research goals were centered around getting these either input or validation metrics for our future model. And on a more individual level, we were excited about exploring the different resources and software available to us to try to generate these metrics, and, learning new ways to sort of organize and deal with these data sets. And as NSF-RU interns, we also got to design T3 curriculum relating to our project.
Yeah, so we were working with data from a lot of different communities, and something that's really important is understanding the differences and the comparisons between these communities. So here's an example of visualization we created just to understand more about the trends.
Yeah, and this table, it's the 4 rural Alaska communities that we took a lot of our primary data from. And it's just a general overview of the different characteristics that they have and sort of how there's a very, vast amount of different types of information you need to consider when trying to figure out what sort of community you should model. And so we use this to decide on modeling Galena. So for research methods, of course, a lot of our work, or at least my work, was primarily in Excel, since I was looking at a lot of different data sets and just trying to compile the data I could and then rearrange it in such a way that it could be generated into these metrics set out by this article on how to validate a synthetic microgrid in the lower 48. And we had a lot of data available to us for these individual communities that ACEP researchers had gathered in the past, but there was certain data holes that we needed to fill. So we also went out and had to find public data to kind of fill those holes. And by the end of this, we were able to generate these metrics based off of rural Alaskan communities and compare it to what people had previously done in the lower 48.
Yeah, and we were working with huge data sets, so we wrote a lot of Python scripts to kind of help us with that process. The different data sets were also varying, so some of that didn't have geographical data tied to it, which meant we had to go into ArcGIS and manually draw out things and measure line lengths that way. And then another portion of this project was just understanding more about the community we were trying to model, which is Galena. And so I got to go and visit Galena and take note of all those big loads, 1 phase, 2 phase, 3 phase, and went to Google Earth Engine and pulled load coordinates, which we're going to be using in our model.
So a lot of key challenges, as I mentioned earlier, was kind of filling those data holes, because we had these different metrics that were proposed by these people who had studied the power systems in the lower 48, and we have pretty limited data out there. We had, of course, data from 4 different communities, but each set only really kind of contributed to certain metrics and not all of them. So just kind of trying to find ways to work with the data we had to sort of either calculate or generate certain metrics, or going out and finding other publicly available data sets to use, as well as trying to figure out the different types of softwares we could utilize to help us in these endeavors, such as Cathy will explain, like Google Earth Engine or QGIS.
Yeah. And some things that we noted that we do differently, like in ByteStore, is to reach out to ask people for data, because a lot of the times that data exists and an email doesn't hurt, and the worst they can do is say no. We also understood when to do things manually versus automatically. That was a real struggle because it was just enlightening to learn that sometimes it's easier to do things manually. And then it's really great to ask questions. So many people here know so many things, and yeah, just have a conversation.
So these are some of the completed metrics that we got over the summer. As you can see, we have criteria, and that's basically the metrics that were put out by the study done for the lower 48. And then we have our own Alaska data that then we calculated or found. And as you can see, it's pretty different. We had to arrange certain things. We had to change such as, we had to change like voltage levels to be more in accordance with that of these rural communities because they're much lower. We also realized that there is a lot more generation like capacity and available generation power in these rural communities just to have backups and such.
Yeah, and so when we're looking at the bigger picture, obviously our end goal is to create that synthetic model of a remote Alaskan microgrid. But the caveat is it should be realistic. We just generated all those validation metrics that are now specific to Alaska. So that's how we're going to check that it's realistic.
Yeah, and of course, future steps with these metrics would be using some of these metrics as actual inputs for an algorithm that we're working on to generate a power network. And then we will build that within Power Factory, simulate it, and create our final model. Oh, and as NSF-RU interns, we also got to design T3 curriculum according to our project. I got to do curriculum on power system modeling, which teaches high schoolers about the different components of power systems and how to like identify them in their own communities.
And we worked with huge data sets. So mine was on database querying, which is how to access specific data from large data sets. The side project coded this website. It's a load forecasting website. Hopefully the audio works. As a side project, I coded this load forecasting website from scratch. First, the user toggles adoption rate percentages in 3 different categories. Then they hit visualize and they're led to a page like this. They can see the instructions and they're reminded of the percentages they inputted in the first page. Then there's this graph. You can hover over elements, hide things you don't want to see. There's even an option to zoom into portions of the graph. And here you can compare elements across different categories. Then you can export the entire thing. Viewing the summarized data, this column shows calculated metrics based on the user's inputs. And there's an About Us page for more information. Thank you. Yeah, so thinking about overall successes of this project, we were able to calculate the input and validation metrics. We settled on a community, which was Galena, and we understood more about the modeling process. And we submitted an abstract to the North American Power Symposium that we're waiting to hear back results from. But the topic of the paper is what Audrey was explaining, how the validation metrics for the US, lower 48, and Alaska are very different.
Yeah, and for our final thoughts on this project, I think the big takeaway was just like learning about the infrastructure of these different rural Alaska communities, how they're islanded and their different approaches to having a sustainable and reliable energy system. It just made us realize like how much more research should be done into these communities. And it's just a really fascinating project.
Thank you so much.
What were some of the limitations you encountered with the different software packages you used?
So a lot of our we had a question about what some of the limitations with the software and programming we had for analyzing our data were. And a lot of the data sets that we had were honestly not necessarily raw data, but some of them were like diagrams and stuff. And so we had to kind of like back calculate some things in certain ways. So I think there were limiting factors in that way. There are times we had to make certain assumptions or had to calculate different things. Yeah, what would you say?
Yeah. I did not like GIS. Personal opinion. It kept crashing on me. The data set was just too large. I had to switch to Google Earth Engine. So yeah, that was a little bit of a process.
With the like website that you developed, like what is your vision for like that or like what purpose?
Yeah, so that's tied a lot more to the Railbelt decarb project is my understanding of it, but it's supposed to be like a way to see how different electrification categories will affect load forecasts in the future. It's supposed to be like a little tool that people can just mess around with and see what they forecast. Hopefully it'll be cool.
How flexible is the model? Because like, this Lena isn't the fishing villages or isn't a fishing village? It's like a very, very different profile.
Yeah, I think there are definitely a lot of things to consider when approaching modeling these communities, because even though they're all in Alaska and face totally different challenges in the lower 48, each individual community are quite different. And, you know, those aspects as well as like their energy infrastructure. So it'd be something we should definitely consider.
We try to keep some things similar, such as, you know, population, number of loads, things like that. But obviously, as you said, like the communities are so different, and it's just going to be something we have in the back of our mind for sure.
Hey, this is Mari. That's really. Can you hear me? Yeah. So really nice work. I'm excited that I think that you both might be staying on and continuing to support the project as next semester. So that's super cool. One question, I think you already touched on this, but just maybe re-clarify. So original intent was to look at a number of communities and kind of figure out some kind of, I don't know if it's an average or whatever amongst all the metrics. Can you explain again? You already did, but I missed a little bit of the beginning, why you ended up selecting one community?
So yes, our metrics aren't primarily focused on Galena in any way. It's actually independent of that, but it is something that in our work we sort of worked on. We didn't touch on as much in this presentation, but we have worked on sort of mapping out Galena in Power Factory. But I guess it is good to clarify that is sort of a separate thing. That's sort of more of the next step for this project. But something we did this. Yeah.
The next step is mapping Galena.
Yes. Well, creating a synthetic power grid for
Okay.
Mari, I can jump in here.
Okay.
So the actual model itself is of an actual place. So it's like geo coordinated specific. And so the inputs are, you know, the actual loads and stuff. So that's why like for lower 48 synthetic grids, they're like of a specific place like Texas, and they use like building location data. So for the actual model, you do need to pick a place. And then you use metrics using lots of communities, data from lots of communities to validate the model out, or the model that comes from like that specific place. So like that's the input is Galena, and then you validate with the metrics from all the different places, if that makes sense.
I think it does, yeah. And I will talk to you guys more this semester as you continue working on it. So I'll learn more about it then. But yeah, super cool, very cool.
Thank you guys. It's another round of applause.